Hello, everybody. Let's see how this works. This is going to be my very first attempt at using Zoom meetings. So it's either going to turn out quite wonderfully or it's going to end in tragedy. I'm just going to give a second here for folks to step into the room. By default, most of you, if not all of you, are going to be muted. So we're going to take a couple of seconds here to let people filter in. And then I'm going to ask you a couple of questions here through an online poll in Zoom, just to help me get a better understanding of who you are and where you're coming from. So let's take a look here. How do I do this poll? Okay, so poll number one is just a little bit about yourself. I'm going to launch it. If you could take a couple of seconds here to tell me a little bit about you, that would be awesome. I see that Terry Brown has a question. Do you want to be able to ask me that question, Terry? Okay, another couple of seconds here to let people wrap up. I'm also watching the chat window, so you'll notice here in Zoom meetings that there's a place where you can ask questions. I will be periodically giving that a look just to see what's going on. Let's see. Okay, thank you, Terry. Okay, so just taking a quick look around here, it looks like most of you are moderately experienced VEX folks. Pretty interesting distribution here between VEX EDR, Cortex, and VEX IQ. So I have roughly half and half of the room here using both platforms. The good news is that the programming we're going to be doing here in Robot Mesh Studio is exactly the same for both robots. So while I'll be primarily working in VEX V5 today, if you are using IQ, the steps are basically the same. Let's take a look here. I have another question here from Kat. Let's see what Kat has to say. Kat, can you hear me? Let's see if I have to do some other things here. Let's unmute. Hello, Kat, can you hear me? Okay, perhaps just write your question into the chat window and I'll get back to it. Okay, other things here that I'm looking at, let's see here, level of experience with programming. Again, most of you seem to have a moderate level of experience programming. For those of you who have no prior experience programming, I'm not going to make too many assumptions about your skill set for today, so you should be fine. And question number 4 asks, if you've ever programmed a VEX robot in the past, what language did you use? And it looks like a lot of you are coming from Robot C, almost 82% of the votes for Robot C. My guess here would be that a lot of you are looking for a substitute to Robot C now that it's been deprecated by VEX. And I'm pleased to show you Robot Mesh Studio, which I think you'll come to love and enjoy. All right. I'd like to say thanks to Kathleen Gately for organizing this meeting. She's the one who kicked me in the butt and said, could you please do this? And here I am doing it. So thank you for motivating me. I'm just going to step quickly into a brief PowerPoint presentation so that I can tell you a little bit about Robot Mesh and Robot Mesh Studio, what we do. And then we'll go through a couple of live demos here. So let's take a peek here at my screen. Okay, so hopefully you can all see that. So Robot Mesh Studio and is made by us here at Robot Mesh. We are an authorized VEX reseller and we pretty much do everything VEX and beyond. We are a reseller for VEX hardware here on the US West Coast. We are the producers of Robot Mesh Studio, which is the software we're going to see today. We do a lot of work with supporting event partners who are hosting VEX robotics competitions. So if you are hosting a competition along the US West Coast, please get in touch with me afterwards. I'm going to be dropping some links into the chat window here, including my email address a little later on, so you can find that in there. We also do student and teacher professional training and development. So again, if you're on the US West Coast and that's something that's interesting to you, again, reach out. I will leave that link in the chat window. We will, if this is a format that works for us all, we may do more of these webinars in the future. So we'll see how this turns out. Okay, so in this presentation, I'll provide a brief intro to Robot Mesh Studio, a browser-based development environment for VEX IQ and VEX V5 robot kits, and I'll show you how you can use this tool with your competition teams. In particular, we will look at installation and setup, robot movement using Google Blockly, and then we will conclude with the competition template. So Robot Mesh Studio is completely free to use, and because it is a Chrome browser extension, it will run quite nicely on Chromebooks. I know for some people that's an important thing. We are not supporting iPads or other mobile devices, but Chromebooks are okay, as well our desktop computers, Macs, and Windows PCs. The software exists basically in two different flavors, an online version, which we will see today, and a desktop version that you can use offline at competitions. The link for the download of the desktop version lives on the Robot Mesh Studio page. Again, these are probably links that I will throw into the chat window. This software is competition legal for VEX programming and has a support for a variety of languages, including Google Blockly, Python, C++, and JavaScript. So I'm going to start by just showing you how to find the programming environment and how to get started with installing it. So let's take a look. I am here in Robot Mesh Studio, and I'm just going to make sure that I have this set up. Let me reshare this. Let's go to 2. Okay, so hopefully you can all see my screen. I'm here at robotmesh.com. And you'll notice here that there's a link that's for Studio, Robot Mesh/Studio. Give that a click. And in a second here, my programming environment will load. We'll notice here on the top right-hand corner that we have a couple of links we can choose from. There's an option here to install the RMC plugin. And if I give that a click, in my case, I already have the plugin already on my machine. But if you did not have the plugin, you'd see a couple of links here that would take you to the Chrome store, and you'd be able to find the Robot Mesh plugin there. There may also be a link here to create an account. It is free to have an account on Robot Mesh Studio. Basically, if you don't create an account, you'll just lose your work when you close the browser window. So I encourage you to create an account. If you are with a child or if there's a student who's 13 and under, we do not collect any ID. Basically, the registration process generates a fake email address so that we're in compliance with the Child Online Protection Act. As far as adults are concerned, we very seldom, if ever, communicate to anyone marketing-wise through this email, so you don't have to be worried that we're going to spam you. It's really just a way that you can come back and find your work. So there's a couple of things we're going to look at here. I'm going to come back into the PowerPoint. So let's just come here. So there's basically 3 styles of programming we can do with Robot Mesh Studio. We can program physical hardware, which we will soon see, both IQ, V5, and the old VEX EDR computer for the Cortex. We can also do something called mimics, and Robot Mesh Studio is unique in the sense that it is the only VEX programming tool currently that's offering simulation support. Some of you may have been familiar with robot virtual worlds, which existed for a long time. Since VEX has bought RoboMatter, they have deprecated that software, meaning that there's going to be no future work done on robot virtual worlds. So we are right now the only game in town as far as simulation of VEX hardware is concerned. We can also, the third thing we can do here is we can program the VEX controller to use it in driver controls. So for those of you who are familiar with VEX competitions, there's basically two aspects to the tournament. One are matches that evaluate your ability to autonomously program the robot, and the other part of the competition evaluates the driver's ability to navigate the robot across the game field. So we'll also be looking at how we can customize and program the controller that comes with your VEX IQ and V5 kits. Okay. Let's take a look at how to do that here in driver controls. I'm going to create a new project here. And there's a couple of questions I'm going to have to ask here in this wizard. The first being, what is my target platform? So in this particular instance, I'm going to program a VEX V5. Now I'm going to be asked what language am I going to program this robot in? And here we can see our choices. The one that I'm interested in here is Controller Express. Again, if we had chosen VEX IQ and gone to language, you'd see that the controller changes to be a VEX IQ controller. So I'm going to step back here, choose V5, and choose Controller Express. Under options here, I have the ability to give my project a new name. By default, the software comes up with a cutesy name. I happen to be Calm Basket. Sometimes it's Whimsical Horse or Happy Grass. But let's call this Driver Control and hit Create. So in a second here, my programming environment is going to load. A little bit about the robot mesh environment. All of these windows can be customized to best suit your needs. You can see that if I take my mouse and pull on these handles, then I can just resize this to give myself more screen real estate. There's also these hot spots on the software, and I can click these to maximize and minimize these tabs. I'm going to switch cameras here. So let's go and share a camera. Go to advanced, go to this camera. Let's see what's happening here. Okay, so hopefully you can all see a VEX V5 driving base. I have a controller. And what I'm going to do here is I'm running the USB to micro USB cable here into the robot and to my laptop PC. And so let's switch cameras. And I'm just going to toggle back to the programming environment. So the first order of business here is I'm going to turn on my VEX robot. So I'm just reaching over and turning on the V5 brain. In a second, it's going to boot up. And if I go over here to these buttons, I can choose Detect Sensors. And in this particular case, the driving base is pretty simple. I just have two motors, a motor on port number 1, and then I have a second motor here on port number 10. Now, from looking at my robot, it might be difficult to tell which motor is plugged into which port. So what I can do is I can hit this connect button, and I can use these sliders. So you can see when I hit this connect button, I get this green bar at the bottom of my screen telling me that I'm connected to the physical robot. And I can adjust these sliders to move my motors. So I'm going to go back into the camera here so you can see what my robot is doing. So this is my robot's right motor. So I have a left motor and a right motor. I've just placed some tape on the wheels so that we can see the direction that the motor is spinning in. And what we might notice here is that the right motor is spinning backwards. So I'm telling it to go forwards, and it's actually moving backwards. So what I want to do is reverse the polarity of the motor. So let's take a look at this. I am going to come back here to my screen. Let's share this. And so I'm going to disconnect from the robot temporarily. I'm going to hit this button. And here under motor 1, which turns out is my right motor, I'm going to give it a better name. I'm going to call it motor right, which means that the motor on port 10 is motor left. And then you'll notice here that there's these gear icons. What I can do is I can actually click on these gear icons and I can change the polarity. So for the right motor here, there's a little option here that says reverse polarity. I'm going to give that a click and hit OK. And so now when I go to look at my motor and reconnect to it, so let's hit connect. And let's change our camera so we can see what the robot's doing. Okay, so that looks a lot better. Now our motor is actually spinning in reverse. So when we tell it to go forwards, it goes backwards, and when it goes backwards, the motor actually spins forwards. This is called reversing the polarity. So that's great. So now we have at least our one motor corrected for. My guess here is that if I turn on the left motor, it's going to spin in the correct direction. And we can see that that is also the case. So let's disconnect and come back to our programming environment. So let's just take a peek here. Okay, I see some questions lighting up on this screen. So give me a second to finish up this, and then I will come into the Q&A and answer those questions. So here's my V5 controller. I have a picture representation of the V5 controller and the channels for it. So what I can actually do here is we can see that on my V5 controller, that channel 3 is my left joystick. So here for access 3, I can add action. I can choose the way that this controller is going to interact and move the robot. So I'm going to choose linear control. Linear control basically just means that we can control the robot in two directions. In this case, either forwards or backwards, left or right. Arcade drive, if you're not familiar, is more like how we would play a video game, in which case one controller can be moved in all directions. For this example, I'm going to be using linear control, and the motor I'm going to be controlling for axis 3, which is on my left-hand side, is going to be my left motor. On axis 2, I'm going to add another linear control, and here I'm going to choose my right motor because this is on the right side of the controller. And with those two buttons set up here, what I can do is I can come up to the top of this window and I can either run the program, which if I'm connected will run the program almost instantaneously. It'll take a couple of seconds to compile the code. The second option here is just to download the program, which will transfer the compiled program to the robot, but it won't start executing until you go over to the V5 or the IQ Brain and find your program to run it. So let's hit the run button and see what happens here. And I'm just going to come back into my camera here and change it so we can see the robot. So let's see what's going on here. Okay, so I'm going to change cameras and let's see what's going on here. Okay, so I'm going to turn on my controller. It's going to take a second for it to boot. And then what I'm going to do here is I'm going to hit run in the Robot Mesh Studio environment. You can see now when I'm moving that left joystick on axis 3, it's spinning the left motor. We can see how the tape is moving. And likewise, when I take my right joystick and press on it, it's now driving the right motor. So I'm going to stop there for an intermission. I'm going to figure out how to use this Q&A because I know there's some people here with ants in their pants who want to ask some questions. So let's just go into the old question box and see what is happening in here. So first person says, sorry, I clicked on my button by mistake. I have a second question. It says, why is there a piece of tape attached to the wheels? Again, for those who missed it, I find that when doing these kinds of webinars, especially if the motors are turning too slowly, that I have a hard time seeing what they're doing. So I just put the tape on the wheels just so I can see which direction the motor's spinning in. You don't have to do that, but it makes my life easier with so many things going on. Are there any other questions that you want to take a moment to put into the Q&A about driver controls or things I may have missed in the setup of Robot Mesh Studio? I'm going to hang out here for a couple of seconds here and let you guys fill my Q&A if you have any questions. Yes, so I'm seeing a question here from Shay saying, is Robot Mesh free? Yes, it is completely free to use. Our software is compatible with the VEX software, and like the VEX software, which is also free, our software is free. Right now, we make all of our money selling hardware, so we hope you have an awesome time with the software, and if you happen to live in our geography, which is the US West Coast, that you buy your robots from us. Our pricing is exactly the same as Robot Mesh, and we're really friendly. And we like helping people. How many people do we have attending the webinar? That is a good question. Let's see. I have 19 people right now in this webinar, plus one panelist, which is me. So there's actually 20 of us all together. I have never used Zoom before. Where are the questions populating besides here? So with the Zoom player, if you move your mouse around to the bottom of the screen or the top of the screen, you'll see a little overlay that shows up. And there will be an option there, I think, to raise your hand, to put a question into Q&A, or to type something into the chat window. My view is a little bit different because I'm a presenter, but I think on your screens here, I'm just going to go over to a Chromebook that I have running as a guest. I believe those controls are in the top left. Let's take a look. Yes, so in the top left of your screen, you'll find your options there to raise hand, Q&A, and to type questions. Let's just take a look here. Is there a way to convert all of my existing code to Robot Mesh? The good news is that if you are currently using VEX Code C++, our C++ and VEX Code C++ are exactly the same, line for line. So in theory, you could copy and paste your code from one window into another. If you're coming from an older programming environment like Robot C, to the best of my knowledge, there is no way to copy and paste your code. But I'm going to leave some emails here in the chat window. So let me pull up some links. I'm going to give you the access to our form and our support personnel. And if you want to try porting over an old program to Robot Mesh Studio, our support team would be happy to work with you. So let's just add some links here for the form. Let's go into my chat. So I'm going to post the first link here, which is the Robot Mesh form. And I also have the email here for our support team, which is support@robotmesh.com. And I'm also putting that into the chat window now. Okay. Any other questions before we move on with regards to driver-controlled programming or the installation and setup of Robot Mesh Studio? Okay. All right. So what I'm going to do then is I am going to move on. If you think of something you'd like to ask, I will periodically be checking out that chat window, and I will be happy to come back to any questions you have on the material that we've covered so far. Let's move on. So let's come back to this PowerPoint here for a second and share this. How do I share this? Let's go and share. Okay. Okay, so we saw how we can program in a variety of languages. Some of the things that make Robot Mesh Studio unique is right now we are the only environment supporting Python programming for VEX Robotics. So for some of you that are interested in teaching an industry language, I personally happen to love Python. I think it's awesome. Google runs on Python, YouTube runs on Python, Spotify runs on Python. Everybody's doing Python. In fact, as of 2018, according to the IEEE, it's actually the most popular programming language in the world. And it has a nice, easy, simple syntax that reads very close to natural English. So if you're looking at a industry language that you want to drive your students towards for VEX programming, Python's a great choice. We do support C++ because a lot of people are coming from Robot C, and C++ is an extension of C. The other thing that makes us special compared to other alternatives for programming the VEX robot is we are in the very early stages of supporting JavaScript programming for the VEX robot. What makes JavaScript an interesting language is that it is event-driven because it was originally built for the web, and now as it's moving out into the physical world, an event-driven language is great for working with sensors, right? So if my bumper sensor bumps into something, do this. Or if my ultrasonic sensor, distance sensor sees something, do that. And JavaScript is very much built with an event-driven worldview in mind. So stay tuned. Sometime a little later in the year, we'll probably build out support for JavaScript. I'm going to be programming in Blockly, but I wanted to show you some of your other choices. So for those of you who've never seen Blockly, Blockly is a tool for learning how to program from Google. If any of you have done Scratch-based programming before, Blockly will likely look very familiar. Blockly uses interlocking graphical blocks to teach computer science concepts, such as loops, decision-making, variables, all that kind of good stuff. The really cool part about Blockly is that it can be used to generate Python. So if we think for a moment that a lot of the core concepts in computer science, like making decisions, working with data, and so on and so forth, are universal to all programming languages. And so if we develop a firm understanding of how to do that using Blockly, in theory, because it generates Python, it should be a lot easier for a novice programmer to move from this beginner's language, Blockly, to an industry language like Python. So let's take a look here at Blockly sitting side by side with Python. On the left-hand side, we have our blocks, and on the right-hand side, we can see the code that it spits out. And as I move into some programming examples here, we'll see this in greater detail. So I'm going to create a new autonomous project. I just want to spend a second here to discuss what's happening in the Robot Mesh Studio environment. On our left-hand side, we have a description panel. The description panel is basically equivalent to your engineering notebook. So for those of you who are in VEX Robotics competitions, you'll know that the engineering notebook is an important part of having a team document their design and thought process as they move through the season. This description panel allows you to capture that electronically for your project. Still use an engineering notebook. That is the only official vehicle for being judged. But this is also a nice addendum to that. If you have multiple people working on the same code, they can see what the original programmer was thinking, and they can document their design here. The second area is the programming area. This is where we're going to be doing all of our coding. What we have below is a program status area. This isn't so important with Blockly, but if we were to be programming in C++ or JavaScript, or even Python for that matter, some of the runtime errors that the interpreter might spit out will show up here. And so we can use this program status area for debugging. I've discussed earlier how there's a couple of different styles of projects we can create. Most of this webinar is going to be focused on programming the physical robot, but as I mentioned earlier, we do support programming virtual robots. And so depending on your project type, if you were to choose a Mimic project, you might see an extra tab where you could build your own 3D VEX model, or you could share an already built model with other people on your team. To the far right is our device monitor. This is pretty much the equivalent of our robot brain. It's going to show us all the ports. So on a VEX IQ robot, we only have 12 ports. On a V5 robot, I believe we have 21. So these numbers may get a little bit longer and come off the screen. If I have set up any keyboard controls or joystick controls, those things are going to show up down here. And then lastly, here at the top, I have my program download, debug, and run screen where I can transfer my program to the physical device. So with that out of the way, let's take a look at a new type of project. And so I just want to maybe, before I do that, I'm going to actually show you a completed project with all these windows filled out. So every year for the last couple of years, we've been doing Hour of Code. This is our 2018 Hour of Code project. So we have our description panel here on the left, where we have created an exercise for our students to do. You can embed YouTube videos, pictures. It's a rich text editor. Not too many things you can't do. I have my programming environment here, my programming pane in the middle. And then I have a simulation that I can control using this code. So again, if I come up here to the top window and hit run, see, it's going to take a second to compile. You can see that my robot is now moving towards this wall, and it's probably just going to move and turn, and it does that. Yeah, it does a little dance. I'm going to hit stop to conclude the simulation. And I will take a look here now at creating a new project. What I'm going to do again is I'm seeing my little bottom screen light up with all sorts of activity here with people wanting to ask questions. So I'm just going to drop into the old Q&A bin to see what's happening. Let's take a look. How would you compare Robot Mesh to Robot C, which I have previous experience with? So with the primary difference between us and Robot C is that Robot C was a desktop piece of software. Ours is browser-based. In terms of installing the software, there's far fewer headaches in using our software. This isn't so important when you're working as a private homeschool or robot club. But if you are in a school, then you know how difficult it is to get software installed onto school computers. Robot C had support for one language, Robot C, and the Robot Virtual World Simulator. Our software supports at least 5 languages that I can think of, the 4 that we've already mentioned, Blockly, Python, C++, and JavaScript. And there's another language called Flowall, which allows for flowchart style programming. In addition to that, a lot of the ideas are pretty similar. If you have past experience with robot virtual worlds, you may find that the controls for our simulator are familiar to you. So let's just clear that one out. Let's just take a look at some other questions that I have here. Which is harder, programming autonomous or teleop? I would say that well, I'd choose programming autonomous. To be honest with you, I don't think the programming is hard. I think that there's more things that can go wrong in autonomous because you don't have control of the robot. As far as the programming is concerned, teleopt versus autonomous, it's essentially the same. It's just that in losing control, I think that there's more potential for error to be introduced. Okay, let's take a look at that. All right. What other questions do we have here? Where are these links? I am going to take a look here at the chat window and just make sure that you guys can see the links. So let's go and take a look at what's happening in chat. I'm going to momentarily stop sharing my screen so I can see the chat window. Okay, let's see here. So again, I'm going to post the links for Robot Mesh Studio, which is just www.robotmesh.com/studio. Go out there and create a free account. The curriculum for using the Robot Mesh Studio software lives at curriculum.robotmesh.com. And again, I've just posted that link to the chat window. We also have some great YouTube videos on using the software featuring yours truly and some of the other guys here at Robot Mesh. I'm going to give you the link to our YouTube channel, which is youtube.com/robotmesh, and hit enter. And it looks like I'm recording this webinar, so there's a very good chance that if there's anything that you've missed or forgot from today's presentation, it's very likely this video will also live in YouTube. Other questions. Is there a way to recover programs from a robot back to a computer? That is a very interesting question. We're actually currently working on ways to reverse download or upload, will you, compiled code back to the programming environment. Currently, that functionality does not exist, but there's the potential, at least through V5, to be able to pull programs from the brick back into the editor, and that's something we are exploring currently. Let's see here. Shay asks, is the Blockly the same or near the same between VEX Code and Robot Mesh? Interestingly, the VEX Code blocks is also using Blockly, a slightly different version. I would say that the commands used, like, whether it's motor spin or motor run or how they're naming those blocks, the names are going to change. I think the workflow, if you have a program that works reasonably well in VEX Code blocks or in Robot Mesh Studio, it shouldn't be very difficult to translate that program into the other programming environment because they're both using Blockly. It's just how they named some of the blocks might be a little bit different. Let's see what else is here. Is RMS legal for other robotics platforms, for example, FTC? Right now, we do not do anything in the first space. Our software is primarily just used in the VEX competition space. That's not to say that we aren't interested in supporting other tournaments. We're basically a very small office. There's only like 4 of us who work here. So we just decided to draw a line in the sand and say, we're going to do VEX stuff today. And if there's enough people out there who like it, perhaps we will expand in a future date to support things like First Lego League and FTC and those other things. So let's take a look. But if you are using our software for competition, it is legal to use in a VEX competition. Other people are saying we can't see the links. Again, if you are having trouble seeing the links in the chat window, let's just see this. I'm going to try and resend them now. You can also email me at chris@robotmesh.com, robotmesh being one word. Let me play with my settings here in the chat window and rebroadcast these links. So let's, I've changed a couple things. I'm going to resend the link here for Robot Mesh Studio. So let's do this. The links for our forum, I'm also going to dump back into the chat window. And our curriculum, which is curriculum.robotmesh.com, I am going to dump into the chat window. And it looks to me like all what I had happening here in Zoom is Zoom allows you to segregate your audience based on panelists, being me, and the rest of your audience. So some of these things are just that I'm a Zoom newbie, and perhaps if I have an enjoyable time today, we'll do more of these Zoom sessions and I'll get a lot slicker at it. Let's just take a look here. So I'm going to clean up some of the questions here in my inbox. Is there a way to code with Java and not JavaScript? Interesting. Yes. Some programming environments like Lego, I'm thinking of Lego Mindstorms, support Java-based programming using LE-JOS. It may be something we do down the road. My personal opinion is that Java is really cool. There's a lot of things you can do with it, especially in the larger context of programming for the World Wide Web. But in terms of similarity, it's very similar in syntax to C++. So if you were wanting to go down Java road and wanted to try heading in that direction using a VEX robot, right now your best choice is probably to program the robot in C++ because a lot of the syntax is very similar. At an unknown future date, we may support Java in addition to all these other languages. So I hope that helps. I'm going to close that one up. Okay, so just give me a second here to tidy up my inbox here. And if there are not any other questions here, I am going to move on to autonomous programming. So let's just take a look here. What else is going on? Okay, a couple more seconds here at my end. Alrighty. Let's move on then. So I'm going to go back to my screen here, my programming environment. Okay, so hopefully everyone can see the Robot Mesh Studio environment. You'll notice here at the top left-hand side of the screen, there's a breadcrumb. So I can move from the projects I've created and come back up here to my root folder, which has all of my projects. If, for example, this was a project that I put much time and labor and love into, and I wanted to share the project with other people, there's two ways that I can share projects with members of my team. Because this is a copy of the project, let's move into a different example where I have the option to share. If I click here under options, you'll see a little gear icon. I have the option to copy a project and to set the project's visibility. So projects that are private are exactly what they sound like. It means that only I can open and close the project and edit it. If I take a look at these copy project restrictions, I can decide what capability or functionality is allowed for in the copy project. So I might want to create only a read-only version of the project as an example. If I come back up here to the privacy and I change this to public, then what will happen is my project will be available for the whole wide world to see in this public tab. So if I come back out to my projects view, and we'll just give this a second to load. We can see here that there are two tabs. There's a featured and public folder. And if I make a project public, then anyone, and by anyone I do mean anyone, can come in here and download the project. For some of you who are on competitive robotics teams or maybe only want to have projects that are shared between members of your classroom, there is a teacher's license. Right now it sells for about $100, and it allows you to manage a closed group of students. So perhaps you only want to share your projects with members of your own team and not with the whole wide world. I would suggest investigating our student license, which you can find in our store at robotmesh.com. I perhaps will hunt for those links a little later on and drop them into the chat window. Let's take a look here. Okay, so let's create a brand new project here for my VEX V5 robot. And what I'm going to do here is I'm going to click on Create a New Project. And again, it's going to ask me for my target platform. So I'm going to choose V5, but if you had an older EDR Cortex controller, you would find it here as well as the IQ. The language I'm going to choose is Blockly. And then, of course, if I wanted to give it a better name rather than Polite Mouse, although I think Polite Mouse is kind of cute, I might call this, let's call this Simple Movement. And hit Create. Okay, so a couple of things here. I happen to have the robot already turned on, so it found my two motors. If it had not populated these fields, if I had clicked detect sensors and the robot was connected and powered on, these fields would light up. So again, you'll recall that my motor on port number 1 is my right motor, and my motor on port number 10 is my left motor. So let's call this motor left. And because this is a new project, I'm going to have to reset the reversed polarity. So I'm going to click on this gear icon and change it so that my right motor spins in the same direction as my left motor. Okay, so I've hit OK. And what we have here is we have now our programming environment, and we have a library of blocks on the left-hand side. If some of you are having a hard time seeing this, on the right-hand side of the programming environment, bottom right-hand side, I can magnify my view or shrink it. There's also a trash can, and if I grab blocks, I can drop them into the trash can and delete them. Every Blockly program starts with a start block, and so we can see here is that the functionality has been distributed into different clusters. All of the generic blocks related to starting a program and printing status messages to the screen are all here under Robot Mesh. So I'm going to grab a start block. And if I were to say, try and make this robot move, I would go into my motors library, and I'm going to just zoom out a little bit so we can see what's happening in the motor library. all of my blocks related to motor movement are found here. Now, generally speaking, the Blockly editor is set up so that the more commonly used blocks are at the top of the screen and less commonly used blocks are at the bottom. That's not always the case, but it's a good rule to live by in the editor. The other thing we might notice here is that some of these blocks are colored. Is there any significance to the coloring of the blocks? And the short answer is yes, there is. In a lot of cases, the blocks will be colored and grouped together based on functionality. So we can see all the blocks related to mathematics are in this kind of royal purple color. Text is in this teal green. Logic blocks are in blue. With motors, there's something interesting happening. There's two styles of motor blocks, gold and red. Gold, and the distinction is really on how the Python interpreter, which is running behind the Blockly, executes these blocks. So gold blocks are called flowing blocks, meaning that as we build our program, so I'm just going to snap blocks together. I'm going to choose, say, for example, a motor and set its speed. And then maybe I want it to do something else. So it's going to maybe do that for 3 seconds. These gold blocks, I'm just going to grab another gold block. So maybe I want my left and right motor to both spin at 50% power. When the program interpreter, the Python interpreter starts execution of a program, it's going to start these gold blocks and then right away move on to the next block in the sequence until there's no more blocks left to execute. We call these gold blocks flowing because they start an action, but the interpreter does not wait for that action to conclude. So you'll notice frequently with gold blocks that they use keywords like spin or begin or start. And so let's take a look, like spin, set, start. These are all keywords suggesting that some kind of action is going to start. Red blocks, in contrast, are called blocking blocks, meaning that as the Python interpreter is bouncing and working its way down the sequence of blocks, when it hits a red block, it's going to wait for the terminating condition in the red block to be satisfied, meaning that, for example, with this red block, it's going to hang out here. The interpreter is going to hang out here until 3 seconds have elapsed. Or let's take a look at another red block. If I grab this red block here and see how it's different from the gold blocks, I'm going to choose a motor and it's going to spin forward, but now it's going to keep spinning forward until a terminating condition is met. For example, until my motor has spun 90 degrees. Or let's say maybe my right motor here is going to spin in reverse for 12 seconds. And so in this way, unlike these gold blocks, until this condition is met, until the left motor has spun for 90 degrees, or until the right motor has spun for 12 seconds, the program will be paused in its execution, meaning it won't execute any of the blocks that are down here until this condition is satisfied. So the key takeaways here is that when using gold blocks, such as I've done up here with these spin forward, I have to create a terminating condition, which in this case is I have to set a wait for block, meaning that these two blocks are going to start right away, and then the interpreter is going to wait 3 seconds, or it's going to sleep for 3 seconds, and then move on to do something else. If I have not used, if I want to use these red blocks, so let me just toss this off this screen so I can either bring it out here or I can take it to the trash can. Let's move these red blocks into the start sequence. So now what's going to happen is it's going to first turn this left motor 90 degrees, then it's going to turn the second motor, the right motor, for 12 seconds. And in fact, let's see what this looks like here on camera. So I'm going to change my view, and just so we can see here, once I've built this program, all I'm going to do is I'm going to hit the play button to run my code. So let me change my screen share, and then we'll hang out for a couple of seconds and we'll pause for questions. So I see questions coming into my inbox, and I will be with you shortly. So let's go to share, and let's share my second camera here so we can see the robot. Okay. So what I have here, you'll recall, is I have my left motor spinning forward for 90 degrees and then the reverse motor for 12 seconds. I'm just going to line up the tape so we can see this here being my left motor, this here being my right motor. So let's take a look at what's going to happen when I hit run. And actually, I'm going to stop the program here, and I'm going to make this more dramatic. So 90 degrees wasn't a lot. Let's make the spin for, say, I don't know, 240 degrees. Let's do something a little wilder here. So let's hit play, and again, I'm going to set the tape so we can see what happens. So we see the left motor spin, and then we see the right motor spin, right? So first, the terminating condition in the first block is met, and then it's met in the second block. And now 12 seconds is quite a long time, so I am going to hit stop. Let's contrast this now with gold blocks. So I'm going to step out of this here. So let me come here and stop sharing my camera and come back to the program screen. So let's share my editor. And then I'll stop for questions. So just hang on a minute here. So here I had my two red blocks. I'm going to get rid of this, and let's change it back to how I originally had it set, which is to use the gold blocks. So here I'm going to set one motor here. You can see there's a little hazard sign that's saying, hey, you haven't assigned the motor yet. So I'm going to say, you know, spin the right motor at 100% power. So that's going to be the motor that's closest to our camera. And then go over here and spin the left motor. We're going to make the left motor spin really slowly so we can see what's happening and contrast the two. And then right now I haven't set a terminating condition. So if I were to run this code, the robot would run for about a second and it would stop. So let me here add a wait for, or a sleep block as we call it. And we'll set this sleep block for 10 seconds so we can see what's happening. Again, what will happen is I will hit the play button to run my code. But before I do that, I am going to come back to my camera so I can see what's going on with my robot. So let's do this. Come back to my camera. And here I'm going to hit the run button. We can see that my right motor is spinning very quickly at 100% power, and the left motor is spinning at 25% power. And it's going to do that for 10 seconds. If I get rid of that 10-second sleep block and throw it away. So I'm just going to stop the program and delete that block. And we're going to run that code again. You're going to see that without that terminating condition, that the robot, the motor spin for a second and it stops. So it's important to remember that when using gold blocks, you need to specify a terminating condition somewhere in your code. If you're using the red blocks, that terminating condition is baked in. Why you would use a gold block versus a red block really just depends on your preference and the activity that you want the robot to achieve. So I am going to hang out here, take a breath, and let's take a look at what's in the old question box and see what I can do here. So give me a second here as I go through this. And I'm just cleaning up some old questions. Let's see. Okay, so I'm seeing a question here from Lily. Is Python used only for major websites like Google and YouTube? No, Python's used everywhere, and it's by and large the most popular programming language in the world for teaching. Certainly in colleges and universities, you'll see Python a lot if you go down a computer science or engineering pathway. Python can be used for AI. So if you're doing stuff that is involved with AI, you'll see Python a lot. Python can do a lot of stuff on the web. So the examples I used earlier were that Google runs on Python, YouTube runs on Python, Spotify runs on Python. I'm sure there's a couple of Dropbox runs on Python. But there's probably an untold number of startups and small private projects that run on Python. And again, its popularity is largely attributed to the fact that it's a much newer programming language. So in contrast, C and Robot C, which is a derivative of it, was created in the 1970s. So computers were quite limited back then. And so, you know, in terms of the programming of the computer and the hardware, it was much more difficult. Python was created in the 1990s, almost 25 years later. And as a result of that, computer hardware got a lot better, a lot easier to use, and the syntax of the programming is a lot easier to wrap your head around. So Python is used everywhere. I love it because we can use it for VEX, and so it's a great way of introducing Python using robots. And then if you had other projects in your classroom, like maybe you're going to do web stuff or do AI stuff or whatever, the kids already know the language, right? You don't have to, you just have to teach them the missing commands, the missing code to work with that new functionality that's outside of the scope of the robot, but the programming is going to be the same. Can this use inches when it comes to how long the motor spins? Yes, you can usually set units of measure. I'm going to switch into screen share mode and see what my choices are. So that is a good question. Let me go and share my screen and we'll see what our choices are here. Okay, so here I am back in the Robot Mesh editor. And if I go and pick one of these red blocks, what can we do here? So, whoops, I'm gonna just check this out. So let's set a motor, it's gonna spin forward, and rather than spinning forward for say, I don't know, 12 degrees, which isn't a lot, we can change this to revolutions. Sometimes here, I think where we're gonna see inches is with the drivetrain. So let's talk about drivetrains because that is a very powerful concept. For those who do not know what a drivetrain is, it's going to allow us to coordinate multiple motors using a single block. So for driving the robot, a drivetrain is incredibly useful. To create a drivetrain, so right now we've just been controlling one motor and then the second motor. What if we wanted them both to work concurrently? Down here at the bottom of the screen, there's an option here for drivetrain. I'm going to click this gear icon. And it's going to say, do you want to enable the drivetrain? I will say, yes, I do. And the left motor is going to be the motor that I said is my left motor, which happens to be motor left. My right motor is going to be motor right. If I hadn't already reversed polarity, it's going to assume that that's something you want to do. So we're just going to leave this checked and I will hit OK. I have a library down here now called Drivetrain, and Drivetrain, here we're going to find ways that will let us move the robot for a set distance. So Drivetrain, drive forward for 50 centimeters. What if I wanted it to be 50 inches? So again, I can go back in maybe after it drives 50 inches. I want my drivetrain to say turn left for 90 degrees. So what we'll do here then is I'll just go into screen share, or rather the camera share, and we will see what this looks like. So let's go back to my camera. Okay, so now I have my drivetrain set for both motors. I'm just going to pull the tape up so we can see what's happening with both motors. And I am going to hit run. So we've set the drivetrain to drive forward for 50 inches. So the little computer that's inside of the motor is doing a calculation. And then what we saw there is that when it figures out that it's hit 50 inches based on a calculation done on the wheel circumference and the track width between the two wheels, then it turned 90 degrees. So again, to show you that, if you missed it, we're going to see both wheels turn forward. So the tape is going to move in the same direction for 50 inches. And now you can see that the tape was spun in opposite directions to make that 90-degree turn. In fact, if I make this turn more dramatic, so rather than 90 degrees, let's make it 360 degrees and hit run and see if we can spot the difference. And so now those two wheels are turning in an opposite direction, right? And they're going to do that a lot longer. Let's hang out here and take a question break. So I'm going to stop sharing and let's see what's happening in the old chat window here. I see some of you are having problems with not being able to see the chat window. For those of you who are on our Facebook page watching this as a Facebook Live exercise, I will post the answers to some of these questions in the chat in the comments section of our Facebook page. For those of you who are coming from the closed Facebook group, Kathleen created, I might create a log of those questions and email answers back. Again, when in doubt, the right thing to do is go to forum.robotmesh.com. So again, I've posted this link now to all panelists and attendees. Go to forum.robotmesh.com, open up a thread, and one of our friendly staff members will be there to help you out. Let me go here into the Q&A and see what's going on here. Aren't encoders necessary for programming with rotations? Yes, they are. In the old VEX Cortex, you had to buy those encoders separately, as I understand. I actually came a lot more recently to the VEX environment. I used to do Lego Mindstorms programming for a number of years. The new V5 motors actually have an optical encoder built into them, so you don't need to buy the encoder as a separate piece of hardware. It's already inside of the V5 motor. If you're working with the old 393 motors for the EDR, then yes, you would need to set up that encoder hardware. And again, if that's something that you want to do, I'm happy to have that discussion with you on the forum, again, forum.robotmesh.com. Okay, what else do we have happening in here? Okay, so it looks like I have answered everyone's questions. With the time we have remaining, because I just want to cover a couple of other short things. Let's go here and share the remaining part of this PowerPoint. Let's see how I can do that. Okay, so share. Okay, just give me a second to set up here. Okay, so we've seen a couple of programming examples. For those of you who are doing V5 programming, this functionality is unique to the V5. You can actually program the robot wirelessly using Robot Mesh Studio, meaning that if you take the micro USB cable and instead of plugging it into the robot, you plug it into the controller, you can send commands wirelessly. There will be a bit of a delay because the program has to be compiled and then it has to be transmitted wirelessly over the radio channel to the robot where the robot's computer receives it and executes it. So compared to plugging in directly to the physical hardware, it's a little bit slower. But if you are, say, you have a robot on a VRC field or on the floor, and you don't want to have to keep picking it up and bringing it over your computer and plugging it in and compiling and then unplugging it, all that just gets to be a little tedious after a while. We could keep our robot on the floor and just send commands to it wirelessly through the controller. Now, one note of caution is that if you have too many people in a closed setting, for example, a classroom, and they're all doing this wireless programming, you will frequently see the controllers drop out, meaning they'll lose connection with the robot. If you were at VEX Worlds this past year, you may recall announcements every couple of minutes about disabling your cell phone hotspot. It was a little chaotic in there, and that's what was happening, is that there's a limited amount of radio bandwidth. And when you have hundreds of robots all competing for that bandwidth in the same room or the same geography, it causes these robots to drop out. I've seen this happen with as few as 3 or 4 robots sitting in close proximity. So if you're working in a classroom setting, be mindful of this. If you're just prototyping and working on this robot by yourself, I personally love the wireless download because I'm lazy and I hate having to get out of my chair to chase my robot. Very last here on the list is I'm going to talk a little bit about the competition template. Many of you are coming to this presentation from a competition background. For those who are new to VEX robotics, as I mentioned earlier, there's basically 2 aspects to the robot matches. There is a driver-controlled period, which is the last minute 45 of the match, and then the previous, the starting 15 seconds of the match is the autonomous controlled part of the match. So you have 2 minutes to do your run, and the first 15 seconds are autonomous, meaning that the player cannot interact with the robot. It has to just run compiled computer code. And then the last minute 45 is your driver controls. This is going to be your team members with their alliance using the game controllers to drive the robot. To facilitate this, VEX uses something called a field controller, which moves the robot automatically from autonomous mode to the driver controlled mode. And we can use a competition template, which is a software template within Robot Mesh Studio that will allow our competition robot to talk to the field controller so that we can participate in both portions of the match, the first 15 seconds of autonomous and the last minute 45 of driver controls. When creating a project, as we've done so in the past, we're going to go through that dialogue, but the very last screen is going, if we look underneath where we would name the project, so here's the default name it's given, there's a checkbox here to use the VRC competition template. If I check that box and I hit create, we will see our competition template. So let's take a look at what that looks like. I'm going to just come back out here and create a new project. So I'm going to create a new project. Again, my target platform is VEX v5. My language is going to be Blockly, although there's a competition template for these other languages too. I'm just going to carry through the example in Blockly. Here I'm going to use VRC competition template, and I'll hit create. And so what's happening here is it gives you three functions. This block here, so your code, when you hit run right now, the code that we put here is going to be the autonomous portion of our robot's behavior. So say, for example, I'm going to recreate a drivetrain here very quickly just so that we can emulate the experience. So let's just add some motors. And I'm going to drivetrain. So say, for example, maybe in the autonomous portion, the robot is going to drive forward, say, I don't know, 2 feet, 24 inches. And then maybe it's going to turn left for 90 degrees. And then maybe it's going to do something else. We don't really care what that's going to be. So for example, here I can just write print hello world to the bottom of the screen. So when I hit run, the first, if I'm plugged into the field controller, this is going to be my autonomous portion of my code. This is the driver portion of the code. So after 15 seconds, it goes back to the drivers. And what's going to happen is all the code related to my controller and anything I want to have happen during the driver portion of the match goes inside of this green loop. So for example here, what I might want to do is go into the V5 controller library. And then for example here, let's see if I could set a controller here. Actually, first I'm going to have to create a controller object. So if I come down here to the bottom of the screen, I see the option for a controller. I'm going to hit click, yes. I'm going to create a controller, hit OK. Now in my V5 controller here, I can do something like, I don't know, for example, maybe my controller is going to print some kind of message to the screen saying I'm in driver control. Keeping this up. I'm going to post a link right now into the chat window, which has a YouTube video where the building of the driver template is explained in a much greater detail than what I've done. As well as if you're new to VEX competition, me and my good friend, Rick Tyler, the one and only, discuss how the VEX hardware is used and how you can emulate the VEX hardware using a field switch. So let's just come back here and take a look at the very last slide here. So in a VEX competition, this is the field controller. It's a big thing, and you typically don't have access to it prior to the competition. So if you wanted to test those behaviors through the VEX site here, you can buy what's called the VEXNet competition switch. It's a pretty basic piece of hardware. You can see that there's just 4 standard Ethernet ports. You're going to plug your controller with the Ethernet cable from the controller into the VEXNet switch. We can either enable or disable the switch, basically on or off, and then we can switch between the 2 modes. So if we wanted to test our code, we could go and move between these 2 modes to see how the robot behaves. And again, that's just something you can buy through VEX. So You guys have been an absolutely wonderful audience. Thank you for missing out on Sunday night or Sunday football to talk to me. What I'm going to do next here is I'm going to ask you to finish a concluding poll. So I'm going to poll you one more time just to see how we did and if there's any appetite for more of these sessions in the future. And then what we will do is if you want to raise your hands or put your questions in the Q&A, I will stick around to answer any questions that you might have. So first, order of business here is I'm going to stop sharing momentarily, and I'm going to just throw up my last poll here. So let's go down here and send out our wrap-up poll. So if you could take a second to fill this out, that'd be absolutely awesome and much appreciated on my part. And hopefully you can see the poll. It says that it's showing on your screens. Okay, so I'll give you another couple of seconds here, and then we'll move into questions. Okay, so 6 of 18 of you have voted, so 38% of you have voted. We'll just hang out here for another minute or two. Okay. I know some of you might be coming to us from outside of our Facebook group. In the future, videos like this, including YouTube videos, YouTube tutorials, are likely to be posted on the Robot Mesh Facebook group. So for access to better information more frequently, I highly recommend you become a fan of us on Facebook. We also exist on Twitter at twitter.com/robotmesh. And again, I'll just throw those links into the chat window. Facebook.com/robotmesh and Twitter.com/robotmesh. So 62% of you have voted. Are there a couple of people who fell asleep? Let's see. I'll give you another couple of seconds and then we'll go into questions if you have any. And if you have no questions, then I wish you a safe, rewarding, and relaxing remainder to your weekend. So just to give you a little bit of feedback here, because you may not be able to see the answers to the poll here. Should we do more of these webinars? 100% of you are content to ruin my weekends in the future. I will gladly do that. If there's demand for these kinds of webinars, we might wind up at a schedule where we do these bi-monthly. I know the beginning of the school year and the VEX robots competition season is kind of a hectic time and a time when information like this is needed. So we might make this a reoccurring event. Hopefully I wasn't too rusty here with Zoom. I promise to get better at it. What time works better for you? Almost half of you said that you enjoy this time slot, weekend afternoons. What topic should be our next webinar? 50% of you said VEX robotics competition tips and tricks. For coaches, I have good news for you. For those of you who know, you know a little bit about Robot Mesh, we have a wonderful fellow here named Rick Tyler. He was the past RECF lead here on the west coast of the US for a long time. He managed RECF in California, Washington, Oregon, Idaho. I think they wanted to send him to Mongolia at one time. He's crazy. He's a VEX dad, and he has probably, I don't know, I'd like to think probably a combined experience of somewhere between 10 and 13 years of VEX experience going all the way back to the dark ages of VEX. And he has offered to come and do a coach's webinar about things you should be mindful of as a mentor. How do you keep a good engineering design notebook? How should you plan out your schedule? What materials and supplies and things like that do you need to have a running chance? And so If that is something that's interesting, Rick said that he would be in touch with me in early October. So we'll see if that might be the subject of our next webinar. I'm seeing that some of you here are interested in the simulation of VEX robots. I am going to put a link to the existing tutorials we have on YouTube for the mimics. I might do a small mini session on how to build a simple mimic. So for now, to get you started, I'm going to type mimic tutorials on YouTube, and then I'm just going to post a link, and I hope that's the right link. And then some of you want to know Python, and in the same vein, I'm happy to do some Python stuff as the topic of a future webinar. The good news with Python is because Python is so popular, you can walk into any bookstore, whether that's a Barnes & Noble or Amazon, and you'll find a gazillion books on Python. And the only things that you're going to have to learn in addition to whatever you read or watch on YouTube or on Udemy is there's some specific commands related to the VEX API. For those who don't speak nerd, API stands for Application Programming Interface, essentially how the software talks to the VEX hardware. So there's some Python specific commands that we need to know to make the motors move and to get data from the sensors. But beyond that, any old garden variety generic Python course, book, or YouTube video will get you on your way to doing Python. Perhaps the subject of a future webinar is going to be on what are those missing Python commands that we need to make the motors move and the sensors to collect data for us. Most of you liked this, this webinar. I'm pleased to hear that I didn't ruin your weekend. Okay, so I'm going to end polling right now. And I'll just share the results since we can do that. And now you can all see the results from this. So hopefully you can see that. And I can see that on my other computer screen. So I'll let that hang for a minute. What I'll do now is if you want to take seconds to throw some questions into the Q&A box, then I will go through them. If you are done with robots for the day, I'm very envious of you, and I will soon join you to watch football. So good day, and we'll talk soon. Again, thank you to Kathleen for organizing this meeting. The initiative was all on her part, and she got me to do this. And I thank her for it, because I think this has been hopefully a productive session for all of you. Okay, so let's take a look here at the Q&A and see what's happening inside of my inbox here. I'm just going to take a second. So Kat has asked, is this needed for V5? I would like you to elaborate on that question. I'm going to come back to it in a second. So if you want to ask that again, I will find you again. Terry says, if you do not start in a competition template and you create your coding, can it be imported into the competition template? That is an interesting question. Let me take a second here in another program here to see if that's possible. I do not know myself. So I'm just, I'm not in screen share right now, but I'm just driving around on my closed monitor here. I'm going to open up a project and see what my choices are. Let's go here. It's just taking a second to load on my machine. So let's create a garbage project. And again, you won't be able to see this because I'm not sharing my screen. Okay, so I'm just going to make something up. Let me print something and say I want to share this. So when I copy this, what are my choices? Copy project. Oops. Yes, so the answer is yes, you can. I'm going to share my screen to show you where this lives. So let's go here. Okay, so let's pretend this is my awesome program that prints hello, and I want this to live within a competition template. Up here in the options screen, if I give that a click, it's going to say, do you want to copy a project? Again, you're going to have to set the visibility. If you're using the free version of Robot Mesh, basically your only choice is to make your project public for the whole world. Again, if it's interesting for you to manage closed groups, I will send a link in the chat window shortly with how we can do that. But for copy project here, I'm going to click on copy project. And if I grab this pull down menu, it gives me all the different choices I have. So right now, this is a VEX V5 Blockly project. If I wanted to make this a project with a template, we can see that there's VEX V5 Blockly project with competition template. So if I choose that and hit OK, Let's see, no competition field. Okay, well, perhaps then what I will do is I will, let's see if this exists here, functions. Nope. Okay, so maybe what I'll do then is I will raise this question with our support team, but it occurs to me that you can or should be able to export your code into a competition template. Maybe that's something to follow up with us on forum.robotmesh.com or on our Facebook channel, and I will get back to you on that. One other thing I wanted to show you that I neglected to discuss during the presentation is this generated code window. So I've talked to you a lot about how Blockly for Vex is a stepping stone to Python. I'm just going to make up some blocks here. I'm just going to add some things here. Say, for example, this motor is going to do something. It's going to rotate for, I don't know, 180 degrees. There's an option here called generated code. And if I hit this pull down menu, this little anchor is actually what I should be calling it, this anchor, what we can see is as I build my Blockly code, so let's create a drivetrain. So I'm going to create a drivetrain and just quickly go through this. So that's motor 10, this is motor 1. And so maybe I'm going to go drivetrain, and then I'm going to go drivetrain. Watch what happens here on this generated code window. So as I move these blocks and attach them, it starts adding the Python in real time, which is kind of cool. And if I want to duplicate any of these blocks, I can just right click and hit duplicate, and I can make copies of them. So I can go like this. So I can say, thanks for attending. So in this way, what we can do is as we get comfortable with these computer science concepts, we can see the code being generated in Python. And at some unknown future date, if I wanted just to start working with this as a Python only project, again, I would come up here to options, copy my project. And rather than it being a Vex v5 Blockly project, what I'm going to choose here is a Vex v5 Python project. And watch what happens when I do that. So now there is no longer a Blockly window. There's just a Python window. So I go for I in range, I don't know, 5, and go print. And then if I run this code, it should just do a bunch of gibberish. So it's making my robot spin, which you can't see, and then it printed hello a bunch of times because I told it to do that. Okay, let's come out of screen share and see what other questions exist here. Okay. So Shay asks, is the competition switch for V5? I used it for V4, but I'm not sure. So yes, the competition switch is the same from the old hardware, the EDR Cortex, as it is for V5. So in that competition switch that you can buy from Vex works for both robots. The field hardware, which is controlling the official tournament match, is unchanged since the old EDR. So this will work for both robots. So let's go on to another question here. When might this archive to this be available? I'd like my students to see this. Wow, okay. So I am going to try and get this into YouTube. Again, a great place to live is to join our Facebook page, because when that YouTube link goes out, I will likely post it there. Also on YouTube, of course, youtube.com/robotmesh. Become a subscriber. You'll see the video. I'm going to create a playlist called webinars. It'll likely live there. Thank you, Terry, for that question. Terry, you also say, if you do not start in a competition template and you create your coding, can it be imported in competition template? I think I said the answer to that, which is in theory, yes. And in practice, it did not work for me when I tried it during this session. So I'll have to talk to the guys about that. Anonymous attendee, ooh, mysterious. Also, if you don't start in a competition template, you can add the start autonomous and start driver blocks manually. I see. So Anthony Bowker, the illustrious CEO and founder of Robot Mesh here, has answered. And again, a lot of the answers to these questions are going to live on our forum or on Facebook. Anthony's saying that you can add these as functions within Robot Mesh Studio. I will quickly show you how to add that functionality.